Hello all and welcome back. So in this video, let us continue our discussion on binary tree and now let's see how can we implement the binary tree in code. So let's get started. Now in the last video, we understood that how binary tree is a generic tree which can have at most two children, right? So the understanding is that though I can still use the generic tree node structure, okay, so we created that structure something like this, where we were having a data and we were having a children. The children used to be a list in which we can have any number of children, right? But what we do instead is we create a node and we say that either the node, because it will have just two children, we say that either it will have a left child, okay, so either it will have a left child or it will have a right child. So we have just changed the terminologies in which we are saying that the children will be known as left and right. Okay, so we will not be maintaining a list, which seems a little uh, better as well, because in list we might have been making a lots of memory, like someone could have added a third child, so we would have need to just always check, right, if that particular node, right, it's a binary tree node or not, if it is having more than two children or not. Instead, we just say that hey, now either you will have a left child or you're going to have a right child. And of course, you cannot have more than that, and you can even choose to have none of that. So a single node is also a binary tree node as well. Okay, great. Now, with this understanding, two things are very important. The very first thing, each of second, yeah, each of left and right node is going to be a binary tree in itself, right? So just like we had in tree, each of these nodes node is also a subtree, so a binary tree. And the second very important thing which I want all of you to realize, okay, one second, yeah, is that now, not sure why I'm not able to make an arrow. Great. So the second very important thing is that now since I am talking in terms of left and right, this particular tree where I have a left child as 2 is not equal to, okay, this particular tree where I have a right child as 2. Again, even though they are having same number of children and everything, they are not equal, because in the first one we have the left child as 2, in the second one we have the right child as 2, so I cannot say that they are equal. Okay, let me write this as well, something which I want you to remember, because many times we are asked, and you will also be doing the question, if the trees are identical, so you will not say that these trees are identical. Okay, great everyone. So now let us go to VS Code and try to code our binary tree node from scratch. So yeah, let's start. This is the file I've created again, binary tree node. Class we will be using, because again we don't have any inbuilt data structure or type which we can use. So class binary tree node, right? We will create a constructor init data, and of course it will have a self. Great. Now in this constructor, first thing is very similar only, right? Which will be data, where I will be putting in whatever data you give me. Talking about the next thing, I just have to imagine my tree something like this now. So my node, instead of maintaining a list, okay, it's actually going to maintain two of these variables. So this is going to be left and right, and it is going to maintain a value. Okay, so this is something what my node will actually be in the memory. Let me make copy of it. Yeah. So this is how actually my overall node will be equal to. Okay, everyone. So let me draw it nicely. Okay. So yeah, this is what your nodes are, everyone. In this, we can have a data, let's say 1, 2, and 3. And actually, I believe it will be better if I just draw it in a different format. So for example, these arrows should be made like this, right? Because now left and right is having the information and not the other way around. Okay, and this will of course be none. So they will be none. So this is how we have to imagine our tree, everyone, right? So we have the data, we have a left, and we have a right. Great. So yeah, let us see and implement this. We will have a self dot left, which I can say as none initially. We will have a self dot right, which again I can say none initially. Okay, great. So with this being done, let us try to create a root. Root is equals to binary tree node, and I'm creating one. And now what I can directly do is I can directly say that root dot left is going to be equal to binary tree node 2, and root dot right is equals to binary tree node 3. Okay, everyone. So I have just connected them now by using left and right. So let's see how that will be in memory. We have created a root which is 1. On its left, I am saying that, hey, you have a node which is 2. On its right, I am saying that, hey, you have a node which is 3. And again, its left and right is none. Okay, everyone. So that's the case. Its left and right is none. To visualize binary tree, actually, I have found a tool which we can, of course, use so that your understanding is a lot better. So pay attention, everyone. I have shared the link of this as well. This is, let's say, our first node. Okay, let me change the data as 1 and edit node. Great. I'm adding the left node. So first I created this, then I'm adding the left node, and we can change it to 2. Edit node. And similarly for this root only, I am adding a third node, which is 3. Great. We are not adding any other child, and you will see that how it is also expecting me to add either to left or to right. Like there is not a single plus after which I can add, because that is how we implement and visualize our binary tree. There's a left and there's a right. Okay, so never just imagine or understand or even visualize it in this way that you will be having a single plus, then you will have another one if you add it. No, we always talk in terms of left and right, and that is, I think, a very important thing to always remember. So yeah, if we just go out of it, then we have a tree which is ready. This is our binary tree, everyone. Okay, so we can see the same in Python tutor, but I believe that it is not that intuitive. Plus it will be on the way similar, but let us still try, because I want that each and every one of you are able to visualize everything. So we have created a binary tree node, everyone. Let us move forward. The node is created. First, we create a root node. So it is having a left and a right, which is none. Okay. Then in the left, directly I am adding the node with 2. So we will see the arrow, something like this. And a similar node will of course be adding. Okay. So similar node is added at 3. We'll just repeat the process. So till now we have the node in memory. Instead of creating them separately and adding it to left and right, what I am doing, all I am doing is just directly saying that, hey, root dot left, please have a node which is 2. Okay, great. So this gets added. Similarly for root dot right, I will be creating this node. So here the constructor gets called. Basic OOPS concept. We will be creating the data. Okay, left and right are going to be none, and then we can add the same. One thing which you will realize, each and every one of them is a binary tree node instance. So they are a subtree or a binary tree in itself. All the terminologies which I explained to you in depth in the last module are very much like valid here as well. Okay, so when I talk about height, when I talk about child, when I talk about parent, descendant, all these are perfectly valid here as well. Yes, we have defined the left and right child now. Okay. But they are still children. Their parent is still one. Okay. So all that things holds true. So yeah, going forward, we will majorly be visualizing like this, where I will help you to see, because I believe that visualizing each and every one of you will be able to understand the same. Okay, everyone. So yeah, that is something which we are going to follow. And yeah, let us meet in the next video. And we are going to now do some operations on specific to our binary tree, because few things are going to change since we have changed the node. The way our node is defined, the most basic structure, because that has been changed. Operations will also change in a similar manner. Okay, thank you.